Test 1, 2. Alright, let's try this other microphone. Test. Hello. Hello? Oh, hi. Hello. I should turn down the audio on my phone. Okay, so I don't have chat over here. I'm just gonna drop that right here. That's that. Let's go there. Oh, that's not good. I misplaced my microphone. My microphone. Oh, there it is. Now, does it have a charge? Well, I don't think it does. Maybe it does. Hello? Alright, let's see if we can do this. It's got a blue light on it, so it's something good. Stick that in my pocket. Alright. Now let's add this. Oops, click here. Mono. And channel number 5. Oh, hey. Hello. Alright. Now we have this here, here, and we got this there. That should be feeding in that way. Okay. Oh, I turned that on. Alright, that's turned on. Okay. Now I see it over there. And now we're talking from my lapel mic. So, wow, that's a lot quieter. Hello. Hello. Whoa, hey there. Okay. So, I think I got that squared away. Hopefully everyone can hear me. Alright. So, I think I got that squared away. I should turn that down so I don't hear myself in the background. Good evening, Scott. How are you tonight? Hopefully my audio is doing pretty good. So tonight we're going to clean this mess up, and I am going to remove this chip and see about reverse engineering this display. But first, I need to clean some stuff up. My desk is a mess. My desk is a mess. Should get back to fixing stuff. Do have some stuff coming in to be fixed. Hopefully it'll be here this week. Probably not stream it though. All right, this is good. We're gonna put this aside, since we know we have working code for this guy. Throw that up there. I may switch to a faster CPU. See if I can drive more than one display. We'll find out. Maybe some other day. Not today, though. I needed a memory stick. Had to solder a RAM chip off this thing. Turns out it was the wrong RAM chip. I could solder back on here, but probably not going to, since I have plenty of that RAM. That's what we're going to work on. We'll use these to try to read it. Maybe later. Put my fancy Agilent Technologies mouse away. Make that fancy thing. Agilent. Put that with my Agilent Technologies keyboard. So put that up here. Put some tools away. So how you doing this evening, sir? Work on anything exciting? How's work going? Staying out of trouble? Causing trouble? Making trouble? I rearranged my bench a little bit. Goal is to make this area, moving the scope and stuff, or moving the soldering station to the right a little bit. Moved my big logic analyzer that's over here. I moved it over here. It is now on this bench. Last week I moved my extra PC downstairs over there, out of the way. Still a work in progress. I have an issue with one of my cameras. I need to upgrade my camera capture card. I think I'm just done playing with trying to figure out which USB port works with what, because God forbid I have too many cam links attached to my computer. It's two cam links is just not, it's not happy with that. And it's complaining. I can't get all my cameras to work at the same time. I had them working and moved my PC. I didn't remember which ports I had everything plugged into. And I have to use ports in the front of the computer, and it's kind of a nightmare. So I gotta look inside the computer to see what I can do. Haven't quite figured out what I want to do yet. I don't know if I can put a larger capture card in my computer, because I don't think I have an available PCI Express slot. I think all my PCI Express slots are being used up. but I'll have to see if I can stick a Blackmagic in there that has 4 ports, and then I can just do all my capturing on one card. Go from there. Don't know yet. So we are going to remove this guy, and we are going to trace out the individual pins. I have plenty of these boards, so if I screw one up, I will not cry. Yeah, I keep cleaning my work area, and then I keep cleaning it again, and then I clean it again, and then I move it, and I change everything around. This is trickier because I got these cameras I gotta fart with. Kind of hard to see what's in focus, what's not in focus. At least I got the lighting good. Got that sorted out. Made some NVRAM modules, which 2 of them worked fine in one board. But when I went to go put them in my game, it didn't work. No idea why. So we're going to use 2 methods to remove this chip. First, I'm going to try hot air. Hot air doesn't work. Then I'll use Chip Quick, which is this stuff right here. Which is this card stuff right here. It's low melt solder. It's actually a lot stiffer, but when you heat it up, it stays molten. So I'm gonna go get something to drink. I'll be right back. Good die. It's blinking at me. I think it's telling me my battery's about to die. I need to figure out a way to keep my microphone from dying here. Hopefully, it'll suck. Keep myself a meat sticker. All right, audio's back. All right, got it charging. Hopefully, we don't lose audio again. Sorry about that. So, it's charging now. So, first things first, let's get this chip off here. I can heat up my meat. My meat's warm. Let the gun warm up. This would be easier if I had a square nozzle. Well, I only managed to lift 4 traces. Oops. All right. All right. Oop, it's a little hot. So clean these traces up on this thing here real quick. So this cools down later. I'll see if I can read it. I don't think I'm going to be able to, but it's worth a shot. Yeah, I jacked up 3 traces on this. Hopefully it's just going to the. Oh, I also melted the plastic on the other side of this thing, which is fine. I'll just know for the next one that I need to take this piece off before it's a little melted. Oopsie. It's fine. You're always gonna break a couple doing reverse engineering, so just clean these traces up a little bit. Just gonna apply some fresh solder on all these traces. And then we want to move the soldering iron in the direction of the traces. That's so we don't rip them up. I'm not going to be installing the chip again. So the traces that are jacked up, I'm going to have to see where they go. I'm pretty sure they just go to the RAM, and I can just remove those. But hopefully they don't. Hopefully they do. We do have a HC573 here, which also looks like it's attached to the RAM chip. So if anything, it's just an address selector, so all these pins won't really matter. Oh, I got that chip off there. All right. So now what I'm going to do is so we have 3 HC4094s. We have 2 more 4094s. Then 1, 2, 3, 4, 5, 6, 7, 8, 9 driver chips. These driver chips are going for the columns. 1, 2, 3, 4, 5, 6, 7, 8, 9. All these are for each individual column, which are all driven by these little tiny transistors, which are then driven by these 4094s. This PCB does have a provision for 2 color LEDs, but they're only using 1, which is red. It had a red film in front of it. And there's all the parts for the second stuffing if we really wanted to stuff an extra part in here. So I'm going to use these probes, because they have a really fine tip on the end of them. Red one. And I'm going to use my fluke meter over here. I'm going to use this meter because it makes a loud beepy noise for continuity, which is very important. Otherwise, you'll be looking back and forth. So that will be used for that. Take these probes and put them over here. Test that. All right. Now what I need is some paper so I can write stuff down on. My microphone. I don't need the soldering iron, so I can just put that right there. So hopefully you guys can still hear me. All right. Well, we'll use these documentation for the Terminator 3 pinball machine. I don't need it anymore. Besides, I printed out like 3 copies of it. The printer was not being very... Yeah, I have a Game Gear that I need to redo myself. So I have a Game Gear, a Nomad, and I also have an LCD kit I need to do. All right, so we're going to take the CPU and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 pins over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 11 here. 3, 6, 9, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right. Let's first get ground out of the way. So we have a 7805 right here. And that should be the ground on this cap. Yep. Let's just go through here and see if we can find all the grounds. Pin 5 down there is ground. 1, 2, 3, 4, 5. This is ground. This is 5 volts. Five going back this way. 1, 2, 3, 4, 5. 5 volts. Make sure it's over here. We have 5 volts over here as well. 1, 2, 3, 4. 1, 2, 3, 4, 5. All right. Now, do is look up a pinout for a, let's just check the inputs of these. Let's take clip. Sorry, sir. I don't know why I did not send you a notice. Doesn't like you. Doesn't like you. It doesn't like you. Hopefully my audio is good. So, for those of you who just tuning in, my friend doesn't like you. I have removed this chip. I'll attempt to read it later. Now I'm just tracing out the pins. I need to look up a 4094. This PC is not hooked up, so I have to finagle this with another computer. So, first I'm just gonna trace these pins and see which pins are going to columns and which ones are going to rows. All right, so the bottom. So this via here. Oh boy. This via here. That is here. So that via so all those are tied to that via. So let's see here. That's good. That's good. All right. So this via here. So this via is, so we're going to check our columns here. So this should all be tied together. Yep. So we're going to take this, we're going to trace from the LED, working our way back to the control chip. So we're going to figure out where this via is on this side of the board. So I can just flip the board over, but it doesn't do me much good. So I'm going to have to put screw meter in here and then go to this side. Figure out where that is. Now I see where it's at. Right here. So all these vias look like, nope. So they're doing, so this via here is for that row. So what I'm going to do is trace this one here and then figure out, what's this guy? So this guy, so the center, so this part is what drives the columns. Now, I don't necessarily need to figure out the rest of these. All I need to do is figure out which part of this device drives that column. It's just this part. So now I'm done. And that's the same for all these. I don't need to necessarily figure out which one goes to each column or anything like that. I don't care. Well, I know they're all going to do the same thing. There's 9 of them. There's 9 columns or 9 rows. Each one of these goes to a row. This is the first row. If we really wanted to, we could probably guess the second row. It's tricky because I have to flip this over and then figure out where the V is. There's a light. So there's the via hole for that. So there's column 2. I bet you this is column 3. This one's probably column 4. This is probably column 5. See, so I just guess on down the line. So 1, 2, 3, 4, 5, 6, 7, 8, 9, just like that. So now we need to figure out what's common between all these. And I'm guessing it's going to be this leg here. So that means this is the input pin. I could look the package up, figure out what the base is or the gate, but these are the inputs on all of them. So now we just go here, and then now we got to figure out which chip's driving this. And it looks like it's going to be this 4094. So we have a 4094. Now, conveniently, none of these chips are labeled, so I'm just going to label this one 1, 2, 3, 4, 5. And that's going to go to pin number. Well, shit. Where's pin 1 on this damn thing? All right, so here's another annoyance. Pin 1 on this package is here. Pin 1 on this package is here. I'm guessing this is going to be pin 1, which is supposed to be, should be ground. Or this one's ground. Is this one ground? Oh, that's convenient. So, sorry, man. Probe's off camera. Sorry. Here we go. Probes. All right. So, this capacitor here. Yeah, the problem is I can't see what I'm doing over here. I don't have 2 cameras. I need to figure out how I can. Let me just do this. Let me see here. Let me see if I can view myself. Oh, audio only. There we go. So now, hopefully, it says I'm live, but it's not showing my video. What's going on here? Gar. Okay, video. Hello. Come on. Seriously? Twitch is not showing myself. I want to view my stream. There we go. Oh. All right. So this is the main filter cap. for this regulator. This is driving this CPU. However, none of these 4094s are on the same power bus. So these 4094s are getting power from somewhere else. So we have to figure that out. So let's just go back to this. I was trying to figure out which pin which was power on this. All right, so this cap. What? Killing me, Smalls. All right, so this is pin 1 right here. On this chip. This is pin 1. Because this is ground. Which is ground on this cap. Which is just so happens not to be the ground on these 4094s. So the ST logo is by pin 1. So, what is the ground for these? That's crazy. So all these chips down here are on a different ground plane. These chips are also on a different ground plane. This is +5. Well, that don't make sense. I just thought I tested this and it didn't fit. What? Alright, well, I'm an idiot. So, that ground, the same as this. These two chips are definitely on the same ground network as the CPU. Great. Same with the 5 volts. We're good there. These chips, on the other hand, do not share the same power rail. These chips are on a separate power rail. Not sure why they did that. Not sure if anybody's still listening. And apparently my chatbot's not working either. Chatbot. Stream is offline. No, it's not. Nice switch for de-offing my client. That's wonderful. Talk about a pain in the butt. What the hell? Successfully connected, but I can't post it. Like it's in the bot. Alright. Alright. Hello, sir. Alright. Well, I was over there. I could have looked up this 4094. Wow.
Hi everybody.
4094 is an actual LED shift register. Let's print this out. Oh, man. My printer was already on. Yay, my keyboard's no longer working. What is going on over here? Oh, keyboard is in game mode. Error printing to printer. Thanks, printer. To printer. Alright. Alright. 4094. As you can see, it is designed to drive LEDs. And it looks like it's 8 bits. So pin 1 is so pin 3 is clock. Pin 2 it'd probably be better if I actually got the right directions, but this had this pretty flowchart, a pretty wiring diagram. Normally I pull these low. There's a clock signal. Pin 3 is clock. So one's strobe and one's data. Downfall is it's not labeled. Not really care at the moment. We can figure that out later. And this one's output enable. And this is how these chips up here in the corner are laid out. These ones are right here. So just put that off the side there. Don't really need to see that. So we're going to look at these transistors here. This is the base of row 1. This pin 4, which is the actual first output. This was number 2. All right, 5. All right. Very predictable. This should be over here to number 14. Very predictable. Very predictable. Predictable. And then this guy is the first chip over here. And then the rest of these aren't used. All right. So 4094 number 4. So this is 1, 2, 3, 4, 5. So bits 0 through 7 are for column 0 through column 7. And then 4094 number 5, bit 0 goes to column number 8. That's 0 index. So column 0 is the bottom as opposed to saying column 1. So that's how these guys work. Now what we need to figure out is where pin 1 is going on these. So let's see if pin 1 is tied to, let's see if the clock signal is tied together. Clock is tied together. Let's see if strobe or data are tied together. Nope. All right, so pin 1s are tied together. So clocks are tied together. Strobe, maybe. I don't know which one's strobe. Data, maybe. We'll just say pins 1 tied. We'll check the clocks on these to see if they're tied in down here. No. Nope. Nope. See if the output enables are tied high. No. They are tied together. So the output enables are tied together. So now let's see if the output enable is going to directly to the CPU. No. I swore I just checked this. Output enables are tied high. So, again, like the other display we saw, the output enables are always tied high on this. Which sucks because we can't just turn that row on or that column on and then, or turn the row on. This is all a row driver. I can't just turn this row driver on and then pulse output enable. I have to basically load up all the column bits for the whole display and turn on the column, turn on the row. That sucks. All right, this blows. So they're using two shift registers. The output of this shift register isn't driving this shift register. So I have to shift out, and the bits aren't tied together. So I have to shift this one, 1, 2, 3, 4, 5, 6, 7, 8. And then I have to shift this one for 9. The engineer who designed this probably shot himself. Okay. That's just a nightmare. So basically, I'll draw that out. So we have a clock signal. And you're seeing my screen upside down. Yep. Not going to be able to draw it for you. Sorry. Yeah. All right. Let's see if we can. Let me see if we can fix this so you can see what the hell I'm writing. Let's see. Ta-da! All right. Can't fix that problem. All right. So the 4094s, we have a clock signal. So this will be their clock signal. So on the rising edge of this clock, it's going to take, if there's a strobe and a data. Right? Maybe. Let me just check that real quick. This chip's used for just about everything in the planet here. Strobe. Strobe is the actual latch. Everything, so you can output data through this like that, and then each clock pulse, it's going to see whatever this value is, and it's going to load that out on the register. So this will load out, and then only when strobe goes high like that, it will take the serial data it received and then put it on the output. And it will stay on the output until it sees another pulse. So then if I hold this low for 8 clock cycles and then pulse this again, hold this low and then I pulse this again, then it will clear the output. Problem here, I have to, this really is annoying. It's going to require a little bit more ingenuity to get that, this display to work. If anything, I might just do is rip these 4094s off, just take these 9 bits, and just run them right to the CPU. I may end up removing half these parts and just using the driver chips. If they would have used a different controller, on this board. They wouldn't have needed to use this RAM on here, which really they gave them a shitload more I/O. Oh, dude, this is gonna have bodge wires all over it, man. This is gonna be bodge wire heavy. But I mean, if we stick a little microcontroller right here, it's literally just gonna be 8 wires over here, and I'm hopefully. See, what I would have done. See, I wish these had an output on them. Let me just check to make sure you don't have cascade outputs. They do have an output. And 9 and 10. Alright. So these do have cascading outputs. So 9 and 10 is cascading outputs. So these two that aren't tied together, I bet you this one, yeah. Alright, we're good. So the output of this cascading goes into here. These both have the strobes hooked together. So we only have to send data into this chip. We send the 9 bits into this chip. First bit goes here, second it'll go down, and then it comes out this port and then comes into here. So we'll send 9 bits to this chip, and then we hit strobe, and that'll turn this on. The cool thing is if I send 9 bits all high and strobe it, it'll turn all these on. Don't really need to do that. Like if I could figure out a way to compress an image and say, okay, I know all these, I could turn all these LEDs on first, and all the, you could figure out how to do that. But like if this row, and this row are the same, I could technically load the value for this row and then turn those 3 rows on. But it's compression, no. So the cool thing is this chip drives this chip, so we only need to now worry about the data, the strobe, and the clock signal off this chip. It drives this one. So this is our strobe input. This is our strobe output, which then feeds into this one here. This pin 9 goes into pin 2 of this 4094. So that's the strobe. That's the data. And these are the strobes. So pin 1 is strobe, which I got back there, tied together. And pin 2 is data. And then clock is pin number 3. Sucky part is this clock 3 is not down here. So don't know what's driving clock 3. Let's see where clock is going. The clock is actually going right there. That's weird. I just heard that thing beep again. All right. So our clock pin is right here. This is the clock for the row. Now we need to figure out the data pin. Right here. Data row. And I bet the one next to it right here is going to be our strobe signal. Oh, I lose. Strobe is pin number 4. 1, 2, 3, 4. So this is strobe row. So we have 3 pins to drive all 9 of these. Now, I would have probably used something else other than this configuration. I would have used maybe a binary thing that could just take, because it's only 9 bits. So you could take a chip that has 4 inputs that gives you like a 74LS32 or something. You could put that in there. And then you could have just said 001, 002, 003, or 111. Like you could have just simply just written 3 bits at one time and it would have turned that row on. Instead, so if you think about it, that's literally 2 assembly line language. So you're literally set the port and then it turns the column on. Clear the port, turns the column off. All right, man, have a good night. But instead, they use a clock, a strobe, and a data pin. So they got a clock 9 bits out, strobe it. That's like 10 or 15 opcodes. And they could have just, so they could have done a lot of code construction, and they could have just used one 74LS32. No, there's no features. It's just, they had a shitload of, I mean, if you're building this board, it would have been easier to just order a bunch of 4094s and stick with 140. Yeah, that's exactly what it was. Instead of having a different chip, they're like, we'll just reuse a 4094 on the whole board and go from there. All right, so now we need to figure out the columns. All our strobe pins are connected together. This did just beep at me. And naturally, so it's going to a small resistor block right here. So I'm wondering if all these other signals are going to the same resistor block. All right, so we have, looks like we only have one of these right here. So we have a 10K resistor block. Pin 1 of this resistor block is going to strobe. Pin 3 is going to data. And 1, 2, 3, 4. Pin 5 is going to clock, which means that, see, that's another weird. So they have this resistor that's like this. And these have resistors like this. So normally you would make this one side of the circuit and this the other side of the circuit. So they have this going to strobe. They have this one going to data. And then they have this one going to clock to the isolated side of the circuit. Yes, they are, aren't they? Ooh, sexy. How you doing, Skidoo? How are you this evening? Having a good day? We are currently reverse engineering a LED signboard. I have about 50 of these. Unfortunately, the company that makes them is not sharing any programming language for them. So I am reverse engineering the circuit and going to build a little microcontroller that I can just attach to the back of this, run some wires, and then drive it and make it do things. Like a smiley face or something. Emoji. Or I can tie it into my chat, and then when people chat, it will make smiley faces. And people can control it from chat. So far we have reverse engineered the column. So the rows are all tied. So all the rows are tied together. The cathode or the anode. Haven't figured that part out yet. And all the columns are tied together. The columns are driven by these transistors down here, which are then driven by these 4094 serial drivers, which this is what they look like. That's a 4094. Basically has a clock signal, a data signal, and a strobe signal. And then this pin 10 is an actual output. So if you send more than 8 bits to it, they start falling off this port onto the floor. So for instance, there's 9 columns on this, 9 rows. So they use 2 of these chips right here. The output of this chip drives this chip. So we only care about the input of this chip. And I've traced those over to the board. And then those are the 3 pins. So now what I'm working on is the actual column drivers. So the outputs of the column drivers do appear to drive each other. And the clocks are all driven together, which is good. So then 20 whatever bits to here. Now the question is the output enables all tied together? Okay, so unlike the rows, the columns can be turned on by strobing them. So in this case, what we're going to do is we will load up the row data first. Then we'll load up the column data, turn on the column data for a given amount of time, turn off the column data, and then reload the next row. So load this real quick, load this data. Now, if we had two CPUs, we could have one CPU do this, one CPU do that. But we can easily make this a simple function to drive this, like turn column 1 on, column 2 on, and that could be a really small function. It does one little thing that could be super fast and efficient. Cool thing is we'll just basically make that a value, like turn on row 0, like, and then it just sends out the bits needed for that and turns it on. And then we just go up and down. And then the columns will be the tricky part. So, and we'll probably do that next week. Let's get this reverse engineered first. And then what I'll do is I will probably hook up some bodge wires off of this thing so I have them. I'll probably remove some of these extra parts that I don't need. I don't need this RAM. Now, I won't just rip this RAM off and throw it away. That is actually a good piece of RAM, static RAM. It's not dynamic RAM, it is static RAM. So I can remove that and I can put it on a little board like this and use it for replace something else, usable chip. It is 256K of static RAM. So, all right, back to this. So again, like I was saying earlier on this resistor pack, normally you would have all your devices on this side, and then so you'd have like input and output side. Hey, Thuggy, how are you? Any word on Ace? All right. Oh, I'm out of hydration. I gotta go get something to hydrate. Be back 1 second. Yeah, I'm slightly parched. I'll be right back. All right, I'm back. I got myself some snacks, some hydrations, and some snacks. This one? Need some googly eyes. Need all the googly eyes. All right, I gotta hydrate here. Love you too, Thuggy. Any word update from Ace? You make it out okay? Yeah. No. That sucks. Yeah, I posted that picture of Snoopy 2 weeks ago for Mother's Day, and when I was over my parents' house, and I kind of knew that he was destined to go to doggy pet heaven, and well, he's up there chasing Ace around right now. So he did love the little ones, so they're watching over us, and that's really sad, and I'm starting to tear up now. So I'm gonna drink some Diet Pepsi before I start crying on screen. Ugh. All right. Now that I have teary eyes, back to what I was doing. Oh. So yeah. So back to reverse engineering this. That's okay. Emotions are good. Just make sure you give George Michael a hug, and all the other Bandit and all of them hugs, and yeah, I only got hammy motes, nothing else. But you can always drop your motes in there. Yep, exactly. Milo, give Milo a big hug. It's gonna be rough for you for the next couple of days. Yeah. It's been a rough month for pets, man. And it's going to be real hard for you. All right. Getting sidetracked here. Back to what. All right. So we're reverse engineering this big, ugly display, in case you want to know, thugs. Trying to make this do stuff. So we're reverse engineering it, and I'm showing Micronis how to reverse engineer and understand how circuits work. Luckily, I got a better microphone setup, and I don't sound like total ass of like last 15 different streams. It is a Bluetooth microphone, which I left plugged on, so its battery went dead on it. So this is I think it's a clone of the Rode. Sounds pretty good. Apparently my sounds are working. I'm not sure what it says. Oh, Thuggy's hosting me. Well, thank you for the host. I appreciate that. So, yes. So back to the streamy thingy here. So, like I was saying, the little resistor here is kind of ass backwards. They're using inputs on one side and inputs on the other side. Horrible design idea, but considering, yes, please cuddle, give Milo a big hug, George Michael a big hug, Bandit a big hug, give all the ferrets a big hug, give them all hugs. Oh, and don't forget Churchill. And hopefully Joe doesn't drive you too much crazy. It's totally okay for you to be non-existent for the next couple of days. And look forward to Toy Story, which I think we're doing Thursday night, which Furix is working. So we might have to move that. So it might have to be Tuesday night, tomorrow night, because I will definitely not be able to be partaking in Toy Story streaming or movie watch on Wednesday night. So I am using a piece of paper. I'm basically drawing it out as I'm tracing it out. So at the beginning of the stream before you got on, I was mentioning how I don't really care about
which row goes where or which column goes where. Because it would be kind of stupid of them to design this as bit 1 goes to row 1, bit 2 goes to row 4, bit 5 goes. If they were doing that, that would be like a form of encryption, but I don't think they would ever need that. Yeah, it would be like that would be like writing software. They're like encrypting it hardware wise, but you could do that if you wanted to keep all the traces clean, and then you could fix it in software. But so we don't really care about all that. So we started the LED. So what I did earlier was I figured out which side of the LEDs were tied together, which side of the LEDs were going this way. So these LEDs, you can see they do turn on. So there's an LED. If you can see it. There's the LED. So all these connect up like this. So if I hook this here, I can go. So you can see the pattern. So all these pads are tied together this way. And all these. Yeah, so all these. So when you went to the Department of Motor Vehicles in Florida, in the county that I live in, you would go in there and say, you're now serving Q43 at station number 5. Well, these were the displays that sat at each of the teller's windows that would say Q145. It would actually show who they're serving next. So these all tie together. These all had an ID pin. You'd hit the button, you could set the ID, and then these would all sit on the people's on the actual areas. I believe these are actually still in use in very many DMVs across the world. They are made in Sweden. Unfortunately, they do not taste like Swedish meatballs from IKEA. So I recommend not trying to eat them. There is lead on here, so it's probably not a good idea. Meanwhile, I'm touching it with my fingers, and I'm also eating cheese earlier. Not smart. So I will die of probably cancer. Yeah, so exactly. So I'm showing you how to reverse engineer this ever so carefully, and hopefully before 1 a.m. because I am going to Universal Studios tomorrow. So, all right, back to where we're at. So the strobe pin is pin 1 on here. Data pin is pin number 3. I bet you pin number 2 is the strobe pin for the other color. Nope. I failed. No idea where this one's going. I don't see an unstuffed resistor array. Not like I really care where it went. Interesting. So the strobe pins for these ones are going to this resistor pack. Pin 2 is the data, is also going to the resistor pack. This guy does not appear to be going anywhere. There's not another resistor pack. Interesting. Well, doesn't really matter. We don't care. So this resistor goes across, and when you go back to resistor view, it should be 10K across it. It says 20K. All right, 103 is a 10K resistor. Of course, I'm blind, so I gotta put my glasses on. Well. So this should be 10K across it. $19. 14. 15. 102 should be a 1K resistor. It's reading 2K. 470 is 470. Maybe not. $12.03. See, $12.03 is 120K. That is exactly what it should be. $47.03 should be a 470K. Yep. 1001 should be a 1K. 1K. So 1003 should be a 10K. Since it's not reading 10K, I'm clearly... Oh, this is a weird package. Okay. So this package is actually different. This has 2 lugs on the side, which, all right. So this is actually what appears to be this is a SIP package. So it is not, I was originally thinking it was designed like this. I originally thought the package was like this, with the resistor going this way. So I was calling the idiots because that's how I thought it was designed. It is not that design. It is actually like this. There is a bus bar down the middle, and there's resistors like this. And then, so there's 8 resistors, and they're all tied together. It's either low or high. I haven't checked that yet. So, I didn't see the other 2 pins on the end of the package. Let me see if I can show it to you. It's that little guy right there. If you look closely, there is some traces going on the ends of it. I'm not sure if you can see it. I didn't see it until I put my glasses on. So, and we'll just check to see if it's tied to ground or tied to 5 volts. And I need to go back to this mode so I can see what I'm doing here and what I'm doing. That is a pull-up. So that is acting as a pull-up circuit. So there are pull-up resistors on that. And what we can do is we can check this one over here. You see if this one also has pull-ups on it. Excuse me. So this guy right here. So this guy here is being used for the same purpose on these parts here. It is also pulling up. Check from there to there. 5 volts. Still got to figure out what's the 5-volt circuit down here. It is a different 5-volt circuit from this one up here. So they're probably using, it's the same ground, which is good. Right? We did figure that out. No, it's not the same ground. So the ground plane, that's the next trick we need to figure out. Was like, why did they use a separate power bus for this side as to this side? So this are all on its own bus. Now what we need to do is figure out is how this guy talking to this guy. Only I can think of is these chip transistors are being used. Don't think it's going to be that one way over there. So need to figure out how these signals from here get to this chip. Because they don't directly go up here. There's also a little I2C chip right here, serial EEPROM. Another good part to use for some other project. It's 21 megahertz cross oscillator. Could continue to use that. I could use that to drive an Arduino, but it is a really weird frequency of 21.840. No idea why. So you can remove that, that. So these parts are all useless. Still got to figure out how this signal is getting up here though. It's definitely not talking directly to that. We determined this is just a pull-up package. So this is just pulling up the signal. A lot of these transistors. So, oh, there we go. So, wow. So they're probably pulling it from here to here. So this little guy here, I bet you one side is tied to ground. Nope. Tied high. Nope. Tied low. Nope. what strobe is tied to this. So this little guy here, this little transistor over here is strobe. So we have, nope, so this little transistor right here, that little black dot, that transistor is driving strobe. So one thing that I've noticed is this whole lower section is on a different power rail than this section. Not sure why. I don't understand why they're doing that. So you can't just drive the input of this chip from this one because it's really not isolated. The grounds are like, the grounds aren't even the same. It's just, I don't understand. So these little thing earlier that I said was the resistor pack, and it was horribly designed. It's actually a SIP package. It is 8 pins on the sides, and there's actually 2 pins on the end. So there's actually there's 2 pins on the end, and these are all 10, because I was measuring them and I was getting 20K. Yeah, I no idea, dude. You're just throwing shit at me now. I don't know I don't know why this is separate. Because these drive these transistors, and these transistors drive the display. So if you took all these transistors, which they're all going to have a common something. Wow, none of them. What the hell kind of shit is this? Okay, so all these little transistors, all these resistors here, that you find here, this is the common bus for all these displays. They all go through these resistors. They're all 150 ohm resistors. They all go to the collectors, and these all go to the outputs. This is a strobe, so this is the output that feeds this. So this is going to be our ground. So I am reading 190 ohms between this common bus. It goes all the way across. So what I can do is I can look at this bus. There's a via right here. There's a via right here. Via right here. All right, so that goes to here. So this via, which is, so this, and this. So these 4 capacitors here are the filter caps for all these transistors. All these transistors are driven from a positive rail. So this is driven from a negative rail. So these all should be tied to ground, right? Yep. So these are all ground. And then this whole side is the positive for all these transistors. This is most likely driven from this regulator here, which is most likely then driven by the CPU to control brightness. So this voltage can vary to make it brighter or dimmer. There's probably a setting to go in there and change that setting. So I'm gonna probably have to desolder this, which basically means so I can figure out what that part is. There's an inductor on here. So this board is most likely going to become a parts scrap board because I have to remove some of these components to figure out what's going on. I can't read this part number off this chip. It's kind of weird. It has this heatsink on there, but it actually doesn't actually touch the part. So it sinks the current or the heat from this guy through the PCB, which is very odd. So knowing that, this most likely is going to be driven so I got to figure out what drives this guy. There's a 5-volt rail that drives this chip. So it's not the 5-volt rail that drives the actual, and it's not this 5-volt rail. This is most likely the transistor up here. It looks like a diode. It's two connected. This guy, 6402G, looks like a diode. This is probably a diode as well. Yeah, that's a diode. So these two are diodes, which I bet you... How many of these pins are tied together? Not. So that one's tied together. Not tied together. Tied together. Tied together. So this is an input and output. They're pretty much all the pins are tied together. Power feeds. So I gotta figure out which power going where. I'm not too concerned about that. These are diodes, so it probably will take an AC input. Goes to these diodes. Diode rectifies it down. 640TG, 640TG. Not sure what this one is. FR014. These are international rectifier MOSFETs. Over here on this side. LR024Ns. 105Ps. That's actually a recognizable part number. That's a 7805. The output of this chip is driving the CPU. The output of this is tied to the output of this guy. This is the inductor side. It is tied to the ground. Nope. Okay, so inductor is tied to this guy. So this is probably the input. Nope. So power comes into these two. But they're not tied together. So it might be two separate power rails coming in on this. It's interesting because this diode goes into here and it goes to this. The second pin goes into these two and comes out here, and these two go here. And this one goes into this guy. So that confirms that we have two separate inputs for power. Pin 1 is fed through here into this guy. Goes through some resistors. Nope, doesn't go through resistors. Goes to there. Not sure what. Goes to the input of the 7805. Comes out of the 7805, goes into that. Ground side, so we'll take the ground side and we'll see if we can figure out. Alright, so now we have to figure out where the ground is. Yeah, they did. But it's weird they have a separate. Okay. So this might be another diode. Because this leg is tied to this. This leg is tied. Oh, there's two more diodes right here. So we have another half wave rectifier right here. So this guy here is a fuse, 5 amp fuse, or it says 500 M on it. So half amp. This feeds through this diode, then goes through this diode, which then goes to this regulator. So here, input side, banded side, there. So this is a fuse that drives this. Which is weird because how is that working? I'm confused. So this diode, so power comes in through here, goes to this inductor, or fuse, or whatever it is, goes into here, comes out here, goes to here, but also goes directly to this pin. So if this is positive power, this is a band right here, so it's not going to go that way. So power coming into this pin is fed through this network into this chip. This guy here, so power comes here, goes here, comes out here, goes there, I don't know what this guy is. They got these big ass resistors right here. Which one side's all tied to each other. Same goes to the other side. Which goes to this via. Which goes to here. That's weird. So oh my goodness. I have no idea what they got going on in this power circuit. this to figure out where is this ground plane? It's not a common ground. Yeah, it's important because we need to, if I power this up, I need to figure out how to power the whole device. If I can figure out how this power circuit works and how everything gets powered, then it's just a matter of, so for instance, this chip here, that's the strobe pin. I got to figure out where this pin goes. And it's not tied to anything on this side. So, and there's not very many resistors on here. Like, there's no resistor right here. Like, I could see there being a resistor here, being the drive on this, but I, like, there's nothing common between the two. Big old bus bars. Considering I melted one of these already, this really is a scrapboard. I'm wondering, so this is tied to here. Tied to here. Nothing down there. It's like, where is this guy going? No, no, no. It's there. Oh my goodness. So the data I/O pin is all the way to hell over here. This is the data column. So that goes into this guy right here. All right. Now we need to figure out the clock signal, which is going to be this via. Which is this transistor right here. All right, so this guy, and this guy. So let's see if these guys carry anything in common. Nothing in common. This is a pull-up. So as it rests, it's going to be high. So these little transistors are going to be used to pull the inputs low. So we've already determined that this is the output side. This one's the clock. So the clock goes right here. Yep. Yep. So keep in mind, that's going to flip the logic. So most likely, this transistor is going to be driven by another transistor. You would think. But maybe not. Okay, they swear to God. There we go. Okay, I think maybe this goes to here. Comes along here. Goes under this guy. Here? No. Here. Okay. So now we're here. Now we're going to flip this board over. See if we can see where we're at. And we go way the hell up here. Alright. So this pin on the CPU goes to here. So there is our row, our column clock. It is the 1, 2, 3, number 4 pad. This is the clock for the column. All right. Got one figured out. So now that we know that that pin of the chip goes directly to the CPU, we can go the same pin on each of these other ones and chase them out. So the data, my goodness, the data is shared between the rows and the columns. How? Why? Why are you sharing? Why are you sharing? Are you sure? Wow. So, the column data pin and the row data pin are tied together. Oh, that's gonna be interesting. Well, no, because you only strobes. Now, if the strobes are tied together, now we have an issue. All right. So, wow. So, even so, the strobe and the data are tied together. The only thing that's different is the clocks. So, they are literally using the clocks to output the data. So they're latching the data on the clock. Talk about pin reuse. So there's literally only 4 pins being used to drive all these LEDs. 4 pins. Apparently, the rest of these pins on this CPU is being used to drive the RAM. We can't find a processor that has enough static memory, so we'll just put all this extra support chips on here for RAM. There's literally 4 pins. We have strobe for row and column, data for row and column, clock row, clock column. That's it. 4 wires. The good thing is data is only latched on clock. So if I hold the clock low on the column or on the row, nothing gets latched. So you can strobe. You can send out data and then strobe it, and nothing will get loaded because the clock never moved. I'm guessing that's what they're doing. Very, very odd way of running this. Still need to figure out so we know these 4 capacitors here, the positive sides are being used for the column sides, for the columns. This goes to the LED, and then these the bases on these transistors. One, two, so that's cool. Positive side of this guy goes where? Great. Goes to a via I can't see. Goes to a via under the capacitor. So now I'm just probing around, trying to find a 5-volt rail for these chips. Also, the output enable is not driven high like this one. So this is output enable for the columns. So we have 5 pins now. These ones, output enable is just tied together. These ones, it's going through this chip right here. Still don't know. So it's the output enable on this chip, on this resistor pack as well. I don't know. So these guys, this goes to this capacitor here. Go to this thing here. I'm wondering. None of these have the same common hookups. Let's go way up here. Way up here. But, damn it. I want to look at the other pin. Where's the other pin going? Are these just being used as diodes? Yeah, I think these are just diodes. This pin doesn't connect to anything. Every single one of these. Okay. So it's labeled Z13X. There's 1, 2, 3, 4, 5. Not sure what this one's going to, but this one, this one, this one, and this one we have identified as strobe, data, clock, output enable. Not sure what this guy is. What's weird is there a via underneath that guy? Yeah, the via right here. So there to there. You're going over to here. You're going down to here. Okay, so this part has been stuffed on accident. Not needed. This is this was to drive these chips. Apparently they weren't paying any attention. I bet you well, this would be this one over here. Yeah, I don't know what this one's going to. So I have a couple extras. These I'm thinking are going to be Zener diodes of some sort. Since this is a pull up, it's pulling this high. This is going just to be used. This pulls low. Something like that. Just need to figure out how to power this now. That's the positive side. All right. The joys of figuring out where we're going. Great. There it is. Yeah, I'm breaking off too. I gotta wake up at 7 o'clock in the morning and go to Universal Studios, so still can't figure out where this round is. Not sure where it's going. I gotta figure that out. Other than that, we have all our data and clock pins figured out. Have to see if I can look these parts up and figure out what they are. And then go from there. Have a good night. I think I'm gonna pull two. Let me see if I can figure out someone to raid.